This video is about quantum tunneling, which is a super cool phenomena observed in the realm of quantum mechanics or quantum physics. Now, quantum physics is a realm of physics that differs from our understanding of classical mechanics. It deals with molecules on the subatomic level, such as protons, neutrons, electrons, and observes how they interact with each other, how they interact with their environments, and also how they interact with light. So quantum tunneling is a phenomena that we would not be able to observe in our traditional understanding of classical mechanics. Now let's observe an example of how quantum tunneling differs from our understanding of classical mechanics. Now in this theoretical model, if you drop the ball down the hill, it simply would not go over the crest on the other side of the hill. This is due to the law of conservation of energy. The ball does not have enough kinetic energy to make it over the crest and continue rolling. However, in quantum tunneling, if that ball was a subatomic particle such as an electron, there is a theoretical possibility that it will go right through the hill, even if its kinetic energy is not enough to make it over the crest or break the barrier. This is possible because quantum mechanics is probabilistic, meaning that it is based on probabilities. And in quantum mechanics, you actually can never know the exact positioning of a molecule until it is observed. There's a realm of possibilities that a molecule can inhabit at any given time, which can be described by a wave function, as I've drawn here. So in this example, the probability of the electron being in any one given position is based on the amplitude of the wave function. And so as this electron or any other subatomic particle approaches a barrier, the amplitude of the wave function deteriorates exponentially as it enters the barrier. However, in some cases, if the barrier is thin enough, it is possible for the amplitude of the wave function to continue to exist on the other side of the barrier, meaning that it is in fact possible for the electron to travel through the barrier without affecting it whatsoever. Now let's consider some implications of what we've just learned. So in classical mechanics, if the energy of the barrier is greater than that of the energy of the object moving towards it, then the object simply will not break through the barrier or go over it. It will just bounce off and return, which is not the case in quantum mechanics or in quantum tunneling. Another thing to consider is in quantum tunneling, the thinner the barrier is, the more likely it is that the subatomic particle will exist or quantum tunnel through it, because there's less time for the amplitude of the wave function defining its possibilities of positioning to decrease. So if it's a thicker barrier, then there's less likelihood that the subatomic particle will exist on the other side of the barrier. Now you might be wondering why quantum tunneling is so cool and so important. Well, simply put, we would not exist on Earth without quantum tunneling, or quantum mechanics for that matter. I think we can all agree that without the sun, life on Earth would not exist, or at least not as we know it today. The sun provides us with energy that we require for basically everything that occurs on Earth on a daily basis. But have you ever wondered, how does the sun produce so much energy? Well, it's through quantum tunneling, a process called nuclear fusion, which is fueled by quantum tunneling. Essentially, nuclear fusion, how the sun produces its energy, occurs when two hydrogen atoms fuse into each other, and their neutrons actually fuse, releasing energy. Now, in our traditional understanding of classical mechanics, the two hydrogen atoms would simply bounce off each other. But in nuclear fusion, they quantum tunnel into each other, which allows their neutrons to fuse and allows them to release energy, which we experience in the form of sunlight. Remember that I said there was a low probability of a subatomic particle quantum tunneling into each something or through something. However, the sun is able to produce so much energy through quantum tunneling because there is countless hydrogen atoms bouncing around in its core that it's inevitable that at least some of them are going to quantum tunnel into each other and fuse, releasing sunlight, which is why we are able to experience sunlight and the sun is able to produce sunlight.